Hello and hey, ladies and gentlemen. Welcome to the first part of my series, How Realistic Are the Creatures in Subnautica. This is a series where I will be looking at the creatures in Subnautica and trying to figure out how realistic they are in reference to real-life animals. This series will not only look at the design and look at the creatures, but they will also consider the biomes, environment, and they are found in across the game's world. So, let's get started with our first creature, the bladderfish. Now, from looking straight at the fish, it does look rather strange, doesn't it? Perhaps a little bit alien, one might say. Pun intended, of course. But that alone does not make it unrealistic, because there are many strange fishes that inhabit our oceans today. A few deep-sea examples are the deep-sea anglerfish, the pelican eel, or how about the barrel eyes? All those fishes do look rather strange, don't they? Of course, the reason they look so strange is that the environment they inhabit forced them to develop strange adaptations in order to survive. So, what adaptations has the bladderfish developed in order to survive in the environment it inhabits? Well, for one, it has a pair of bladders on the top and bottom of its body, hence of course its namesake. So what are the purposes of these bladders? The in-game databank explains that it uses these bladders for the combined means of propulsion and buoyancy. And from the description, it also states that the bladderfish filters air and seawater to adjust its buoyancy. It also states that the bladderfish uses the bladders as a means of collecting organic particles for sustenance. So is it realistic for a creature like that to be able to do all these things? Well, let's look at each one of these individually. Part of filtered by seawater is not only realistic, it is also something that every fish in our oceans do today. So the thing is that fishes are somewhat less saline than the surrounding water they inhabit. That means they have a little less salt in their body compared to the water they live in. This means in turn that they have to constantly use energy in order to keep the water inside their bodies and not become super saline, basically stopping the water from running under their bodies and essentially causing them to die of thirst. So an alien fish being able to filter the water surrounding it through a semi-permeable membrane is far from unbelievable. It might even be able to filter the salt water that comes through the membrane until it becomes fresh water that the player can harvest from it. The process to do this would use something called osmosis. Osmosis is a process where a solvent, in this case water, moves across a semi-permeable membrane, the bladder, from a less concentrated solution to a more concentrated one. This is a process that every animal on the planet and Earth uses in order to extract nutrients and water. It is also used to preserve molecules and water in places where we want it. This is of course also the general method used by fishes in our oceans today. But exactly how this occurs is rather complicated, and I will not go into detail with it here. But what I will say is that the bladderfish might use an osmotic process in order to remove the salt from the salt water it intakes in order to make it fresh water. Now why would it even do this to begin with? Seems like a lot of effort just to remove some salt from the salt water that the fish is already surrounded by, doesn't it? I mean, is it just for the convenience of the player in order to have fresh water early in the game? I would argue no. The reason for it is that the bladderfish can use the fresh water as a means of buoyancy. To explain that conveniently leads me into how the bladderfish filters air. So, the part about being able to filter air is a little bit strange. Now, believe it or not, there are fishes that are able to breathe air. However, there are very few fishes that use air as a means of buoyancy. An important distinction that needs to be made here is that a lot of bonefishes have an internal bladder called a swimming bladder. This bladder is filled with gas, but it is not collected from the surface, nor is it made of warm or air. Gas is usually something that the fish produce themselves. So it is a little bit strange that the bladderfish filters air to begin with. Secondly, if the bladderfish also collects air, then that means it has to break the surface in order to collect it. This would put the bladderfish at a great risk from predators both above and below. The sky ray can very easily snatch the bladderfish if it breaks the surface, and predators like the stalkers will be able to strike it from below. These are tactics used by a lot of predator animals in our own oceans, and the reason for it is that it corners the prey and makes it much harder for it to escape. So it is a little bit strange that the bladderfish is seemingly filtering and collecting air inside its bladders. But what does this have to do with fresh water and buoyancy that I mentioned earlier? Well, see, fresh water is of course heavier than air, it has a higher density, but it is lighter, a lower density than salt water. And hearing that probably set your head spinning a little bit unless you watch as many nature documentaries as I do. How can water be lighter than water? And the answer to that is, not all water is equal. Fresh water is actually lighter than salt water. And the reason for that is that fresh water has less particles in it than salt water. And the key word here is salt. Salt particles that make the salt water salty actually makes it a little bit heavier than fresh water, and when something is lighter than water is placed inside water, water tries to push it upwards. This can of course be observed when you put an air balloon inside water. Because the balloon is water, i.e. has a lower density than the surrounding water, it floats. The same principle applies to fresh water, just not as extreme. So by filling its bladders with fresh water, the bladderfish might just be able to control its own buoyancy and thus make it easier for it to stay afloat in the water without sinking or floating. The strange part about it though is that the bladderfish collects air to begin with. Like I already mentioned, puts the bladderfish in a vulnerable position when it does it. It also makes it a little bit unnecessary since the bladderfish can already regulate its buoyancy by producing fresh water. Now, when it comes to the part of it using its bladders in order to collect organic particles for means of eating, that is something we do see in a group of creatures that have a spinal cord but not a vertebrae. The group I'm referring to are known as the larvaceae. Now, these may look like tadpoles, but they only look like this on very small parts of the day. For the most part, they live in little houses they make of mucus that are quite the feats of engineering, because they can not only breathe through these houses, but they also use them to collect the organic particles that they then eat. But that's not all that's really fascinating about these little critters. They also make as many as 6 houses a day, because these houses very quickly get clogged up with particles and eventually sink, so they have to leave their house and swim away. Quite productive little tadpole now, isn't it? Anyway, now that I'm done gushing over my mucus-building tadpole, this shows that there is a precedent for the bladderfish using its bladders that are covered in mucus in order to collect organic particles. So overall, the bladderfish does seem fairly realistic, but what about the other parts of the design? The first and most obvious problem with the design is that the color of the bladderfish, or rather the existence of color on it in the first place. Now what do I mean by that exactly? Well, the bladderfish doesn't seem to have any hard scales, nor does it seem to have any means of defense beyond just swimming away. Creatures that don't have any hard scales or additional means of defense usually rely on camouflage. In this case, it would be most effective for the bladderfish to be completely transparent with no pigments to make it harder to see. Now, you may say that the reason for the bladderfish having color is to make it easier for spotter players, especially since it provides fresh water for the player in the early game. And to that I say, I will be ignoring your argument in the name of science! But in all seriousness, for the sake of consistency and analysis, I will ignore the adjustments made for the sake of gameplay and focus my analysis on the realistic aspect. But that will not stop me from making suggestions to make it more realistic. So what would I have changed about the bladderfish to make it a bit more realistic? Well, the good news is it wouldn't take too many changes. Like mentioned previously, I would have the bladderfish be transparent, and I would also have it be present more in the open oceans. The second part I would add is because the bladderfish is described by the Wikipedia as being somewhat jelly-like. Now, the obvious comparison to make is to compare it to the jellyfishes in our own oceans. And jellyfishes don't like being near anything that can resemble a hard bottom or an obstacle. This is because their gelatinous bodies makes them fragile and prone to being damaged by just brushing up against rocky surfaces. Now, the key difference here between the jellyfish and the bladderfish is that the bladderfish can clearly swim against currents and can to some extent control where it's going. For this reason, I would suggest the bladderfish be far more common in the open waters. The problem we would run in here is that the player still needs to get fresh water from something. And my answer to that would be to use the kelp life growth called creep vines. Now, the kelp on our planet has bladders filled with gas to make sure they're constantly pointing upwards towards the sun. This makes sure they can always photosynthesize. Now, as far as I can see, there aren't any bladders on the creep vines, but if there were, I would have them be filled with fresh water instead of gas. This would mean the players would always have a good source of fresh water while keeping it realistic. Thank you for listening. If you like this video, please comment, share, like and subscribe. I'll see you next time.